this lesson we'll just be walking through a few new calculator skills that will be really beneficial to have under your belt for this test that's coming up on Thursday, which will be an exam 2 style test. So please grab your calculator, and it'll be most beneficial for you to actually just work through what I'm doing on the calculator here rather than just following along. It'd be good to have your calculator out. So open up a new document in your calculator, and I'd like you to first just define a function that we'll use as our example that we'll work through. So to do that, let's go to Menu, Actions, Define. Let's make the function f of x equals 3x cubed minus 6x squared plus 1. Alrighty, when you define that, you should have a little message that comes up as done. So the calculator knows now that that function is the one that it's working at whenever we use f of x. Alrighty, if we want to find the derivative of this function, we can go to Menu, Calculus, Derivative. So Menu for 1. We're differentiating with respect to x here, so down the bottom here we'll put x, and then in this bracket here we can just type f of x because the calculator knows that function now that we've defined, and it will give us an output of the derivative, and we would be able to differentiate this by hand as well. So if you'd like, you can go ahead and check it, and that certainly is correct. Alrighty, if we want to find the derivative when x is equal to a particular value, so if we'd like to find the derivative at x equals 1, what we can do is go to Menu, Calculus, Derivative at a point. X is the variable we're interested in. If we wanted to say find the value of the derivative at x equals 1, we can make the value equal to 1. We're dealing with the first derivative here, so that's all fine. Again, in this bracket here, we can just put our function, and then it comes up with x equal to 1 because that's what we've defined. We're looking for the value of the derivative at x equals 1. So we'll get minus 3. Alrighty, so that's if you're looking for the value of a derivative at a particular point. Remember, it was Menu, Calculus, Derivative at a point. Now, if we're looking for, say, the coordinates of points on the curve where the gradient is equal to a particular value. Let's say we're trying to find the coordinates of the points on a curve where the gradient is equal to 5. We can use the solve function. So we want to solve the derivative equal to 5. We can use the solve function, so Menu 3, 1. And we can just type in our derivative here, or copy and paste it from above. And we can solve it equal to 5. So we find that when we solve our derivative there equal to 5, we get x equal to minus a third, or x equal to 5 over 3. And if we wanted to actually find the coordinates of the points where the gradient is equal to 5, so what we've solved here, we can then go ahead and then just substitute these x values into our original function. And that's as easy as just typing f of minus 1 over 3. So that'll give us 2 over 9, so that's the y coordinate then. So we've got one coordinate, x equals minus 1 over 3, y 2 over 9, and then the other coordinate where the gradient is equal to 5 is 5 over 3. And that'll give us minus 16 over 9, so that would be the other coordinate where the gradient is equal to 5. Alrighty, one last thing I'd like to show you is how we can find the equation of the tangent line and the equation of the normal line at a particular point. So if we wanted to find the equation of the tangent line, say when x is equal to 1, we can go to Menu, Calculus, Tangent Line. In front of this, we want to write y equals, so that when we get the output, we get y equals as the form of the tangent line. Then, because we've defined our function in here, again, we can just type f of x. If we hadn't defined our function, you would just go ahead and type in the actual function. So you'd go ahead and type in 3x cubed minus 6x squared plus 1, but we've defined it, so we can just leave it at that. And then if we want to find it at a particular point, so say at x equals 1, you can write comma x equals 1, and that gives us the equation of the tangent line. Likewise, if we want to find the equation of the normal line at x equals 1, we can go to Menu, Calculus, Normal Line. Again, let's put y equals in front. Again, our function, and then let's make it at x equals 1. So that would give us our equation of the normal line, and notice the gradient in the tangent line is minus 3, and as we'd expect, the gradient of the normal line is the negative reciprocal, so 1 over 3. Finally, if we want to graph this function, we can go open up a new document. So let's open up a graph, and in here we can just type the actual function that we defined, so f of x, and it comes up with the graph there. And just to jog your memory, if we want to find the maximum point and the minimum point here, we can go to Menu, Analyze Graph, Minimum. The minimum is between that lower bound and that upper bound. We've got the coordinates there, and likewise for the maximum, Analyze Graph, maximum will be between that lower bound and that upper bound. We've got the coordinates there that we can drag over there to make it a bit clearer.